Hello, so in this video I'm going to talk through this thing called permutations and combinations. Now that sounds really quite complicated, doesn't it? But seriously, it's not, okay? A permutation, I mean we never say permutation. A permutation is just another word for an arrangement, okay? So if you arrange something, you're permuting something, but you know, don't worry about that. Permutation, arrangement, same thing, okay? A combination, well we do kind of use that in everyday language, but combination in this situation is just saying, right, how can we choose something or choosing something? So really when we're talking about permutations and combinations, what we're actually talking about is the number of ways that we can arrange something and the number of ways we can choose something. So let's say, for example, I have 5 objects. I've just chosen that we're going to have 5 cubes, and actually that's the example which I'm going to use throughout this series of videos. Let's suppose I have 5 different coloured cubes, just so I can distinguish what's going on. And the first question which I'm going to ask is, how many ways can I arrange these 5 cubes? Well, let's suppose I have 5 positions to put these cubes in. So position 1, position 2, position 3, position 4, or position 5. Actually, do you know what? I'm going to call them position A, B, C, D, and E. Otherwise, we're just going to have too many numbers going around and worry that people are going to get confused. So, first question is, how many cubes can I put in position 1? Well, are you happy that I've got the grey cube that I can put in position 1? I can put the blue cube in position 1. I can put the orange cube in position 1. Oops. I can put the orange cube in position 1. I can put the yellow cube in position 1. Or I can put the green cube in position 1. So how many cubes have I got to choose from to put in position 1? Well, I've got 5 cubes to choose from to put in position 1. So I've got 5 cubes to choose from to put in position 1. So let's just suppose, let's suppose we put the blue cube in position 1. Just for argument's sake. Well then, how many cubes have I got left to choose from to put in position B? Okay, so in position A, I've got 5 cubes to choose from. Position B, I've got how many cubes? Well, I've got 4 cubes left over. So I've got 4 cubes to choose from to put in position B. Okay, so let's say, let's put the yellow cube in position B. All right, it could, so how many cubes have I got to choose from to put in position C? Well, are you happy? I've got 3 cubes left to choose from. I've got 3 cubes left to choose from, right? So let's say, for example, let's put the grey cube in position C. All right. How many cubes have I got left to choose from to put in position D? Well, I've got 2 cubes left to choose from. I've got 2 cubes left to choose from. Let's say, for example, I put the orange cube in position D. Okay, so how many cubes have I got left to choose from to put in position E? I've got 1 cube left to choose from. Okay, and that is a perfectly valid arrangement, which I've got there. I've got blue, followed by yellow, followed by grey, followed by orange, followed by green. That's a perfectly valid arrangement, but I could equally have different arrangements. Okay, but the important thing which you need to know, notice is the numbers. So in position A, I've got 5 cubes. In position B, I've got 4 cubes. In position C, I've got 3 cubes. In position D, I could choose from 2 cubes. And in position E, I could choose from 1 cube. Okay, so whatever cube is left over, I can put in position E. So this is just, these numbers here just simply represent the number of choices of cubes. So the number of cubes that I can choose from to put in each position. So then the next question is, what do I do with these numbers then? So I've got 5, I've got 4, I've got 3, I've got 2, and I've got 1. What do I do with these numbers? Do I add them? Do I divide them? Do I subtract them? Do I raise them to powers? Do I take logarithms of them? What do I do with these numbers? Right? Well, in probability, we tend to just do 2 operations with numbers. We multiply or we add the numbers together. Okay, and the multiply normally comes from if we're thinking about events which are and events, so one thing happens and another thing can happen. And the add normally comes from if the or event, so one thing can happen or another thing can happen, but they can't both happen at the same time. Now, if you think about the events which we've described here, are you happy that they can all happen? So in other words, we can have 5 cubes to choose from in position A. And we can have 4 cubes to choose from in position B. And we can have 3 cubes to choose from in position C, and so on and so on. Okay, so are you happy then that we can multiply? That we just multiply all these numbers together? But if you're not happy with that, then there is another way that I can explain it, and it's using binomial tree. So let's start over here in position E. Okay, so I'm actually going to work my way backwards, if you like. So let's think about position E. Well, let's suppose, for example, I put the green cube in position E. So how many choices have I got? How many ways are there of arranging just that one cube there? Well, there's only one way of arranging it. Okay, I can only have the green cube there. So you're happy I've just got one thing there. Okay, but then let's work our way backwards. Okay, and now I'm going to have two cubes. So I'm going to have the green and the yellow cube, which I'm looking at. So let's suppose I could have the green cube here. Okay, and then I've got the orange cube here. Okay, but equally I could have had the other arrangement. So I could have had the green cube here and then the orange cube here. Could have had the orange cube here. So are you happy then that what I've got there, how many groups of one have I got? I've got, well, there's one group there and there's one group there. So I've got two groups of one. Okay, I've got two groups of one. Okay, now let's suppose I throw in the yellow cube into the mix. So let's suppose I throw the yellow cube into the mix. Well, then I could have had the yellow cube first. I could have had the yellow cube first, then followed by the green cube, and then followed by the sorry, that should be drawn like that. Followed by the green cube, so the yellow cube followed by the orange cube followed by the green cube, or I could have the yellow cube followed by the green cube followed by the orange cube. Okay, or I could have had the orange cube first. So I could have had the orange cube first. I could have had the orange cube first. Okay, followed by the green cube, followed by the yellow cube. Okay, or I could have had the orange cube followed by the yellow cube, followed by the green cube. Green cubes. So let's think then. Let's think. So we could have had that one, that one, that one, or that one. Okay. Or I could have had the green cube first. I'm forgetting. Could have had the green cube first. Well, then that's that. Then I could have had the green cube followed by the yellow cube, followed by the orange cube, or I could have had the green cube followed by the orange cube, followed by the what's that? Is that yellow? Yeah, yellow cube. Okay, so I could have had this one as well. Okay, so in other words, what I'm saying is, I could have had how many groups of one? Well, I've got 1, 2, 3, 4, 5, 6 groups of one. Yeah, you're happy I've got 6 groups of one on the end. Where does that 6 come from? Well, I had 3 groups of 2. Yeah, I've had 3 groups of 2 because this is one group, this is another group, and this is another group. So I've got 3 groups of 2, so I've got 3 times 2. Then how many groups have I got of 1? Well, I've got that many groups of 1. Yeah, 1, 2, 3, 4, 5, 6. So I've got that many groups of 1. Okay, then I could go further and I could think about the, I could throw maybe the blue cube into the mix. So if I threw the blue cube into the mix, then all I'm going to have to do is do this exact same arrangement again, but I'm just going to have a similar kind of arrangement to this 4 times. So I'm then going to have 4 times 3 times 2 times 1. So in other words, I'm going to have this group 4 times. Yeah. So this is it blown up. So how many groups of 1 have I got? Well, they're right at the end here. I've got 1, 2, 3, 4, and so on all the way down. I'm not going to calculate them all out for you, but I'll end up with 4 times 3 times 2, whichever that works out to be. So 4 times 3 is 12. So 24 groups of 1. So I'll end up with 24 groups of 1 in total. But how did I get that? Well, I just repeated the same group which I had above, just 1, 2, 3, 4 times, because I'll have 1, 2, 3, 4 events now. Okay, of the fourth one comes first. So basically, if you just think about them as groups, then this is what happens. Okay. Now, as you can imagine, this could get pretty long. Let's say, for example, if I had 24, 24 objects that I'm trying to arrange. So 24 objects that I'm trying to arrange. Well, I have 24 times 23 times 22 times right the way through to times 2, 3 times 2 times 1. So I'll have this. So I'll have 24 things which I'm trying to write out. And that just gets ridiculously long. So is there a way that I can compress this down? Because by the way, this is just, it would be 5 times 4 times 3 times 2 times 1 because I've got 5 objects. So is there a way to compress, this down so I don't have to write out 5 times 4 times 3 times 2, just to show that the numbers are just decreasing from where I start. So I start at 5, and I decrease the numbers to 4, to 3, to 2, to 1. Then I just multiply them all together. Okay, is there a kind of a nice way to compress that down so I don't have to write it out each time? Well, yes, there is, and it's used the factorial notation. So factorial notation. Okay, and it's just simply an exclamation mark next to where I start. So this would be equal to, for example, 5 factorial, because you do 5 times 4 times 3 times 2 times 1. So the question is, so the general question is, how many ways can I arrange n objects? So if I have n objects sitting in front of me, how many ways can I physically arrange them? arrange them. Assuming there's no limitations or anything like that. I've got n objects sitting in front of me. I've got n cubes. How many ways can I arrange them? Well, the answer is n factorial, which is just equal to n times n minus 1. So I keep subtracting it 1 each time, so n minus 2, right the way through to times 3 times 2 times 1, whatever. Okay, so I'm just starting at n and I'm just decreasing the numbers by 1 each time and just multiplying them all together. So how many ways are there of arranging n objects? There's n factorial of them. So how many ways are there of arranging 10 objects? It's 10 factorial. How many ways are there of arranging 6 objects? 6 factorial. You get the idea.